Identify the standard reduction potentials from the exam data. According to the table provided in the prompt, the standard reduction potentials, E degrees red, for the two half reactions are silver reduction, Ag to the power plus plus E to the power negative gives Ag quad E degrees red equals plus 0.80 V. Zinc reduction, Zn to the power 2 plus plus 2 E to the power negative gives Zn quad E degrees red equals minus 0.76 V. Determine the oxidation and reduction components of the cell. As established in our balanced net ionic equation from the previous question, the thermodynamically favorable reaction in a galvanic cell must yield a positive overall cell potential, E degrees cell greater than 0. The species with the more positive standard reduction potential, Ag to the power plus, undergoes reduction at the cathode. Ag to the power plus plus E to the power negative gives Ag quad E degrees cathode equals plus 0.80 V. The species with the more negative standard reduction potential, Zn, must undergo oxidation at the anode, which requires reversing its reduction half reaction. Zn gives Zn to the power 2 plus plus 2 E to the power negative quad E degrees anode equals minus 0.76 V. Calculate the standard cell potential, E degrees cell. The overall cell potential is calculated using the formula E degrees cell equals E degrees cathode, E degrees anode. Substitute the values into the equation. E degrees cell equals plus 0.80 V minus 0.76 V equals 1.56 V. Apply the thermodynamic rules for intensive properties. A critical concept tested here is that standard reduction potentials, E degrees, are intensive properties. They depend on the chemical nature of the species, not on the amount of material. Even though the silver reduction half reaction must be doubled to balance the electrons transferred in the net ionic equation, 2Ag to the power plus plus Zn gives 2Ag plus Zn to the power 2 plus. The standard reduction potential, E degrees, of silver is not multiplied by 2. It remains exactly plus 0.80 V. This calculation identifies option C as the correct choice. The correct answer is option C, 1.56 V.